Hi everyone, I am Dr. R. Soumya, Assistant Professor, Department of Electronics and Communication Engineering. Today we are going to see the subject Electron Devices and Circuits. The topic is Bipolar Junction Transistor. So what is transistor? The transistor is the main building block of all modern electronic systems. It is the three-terminal device whose output current, voltage and power are controlled by its input current. In communication system, it is the primary component in the amplifier. An amplifier is a circuit that is used to increase the strength of an AC signal. Basically, there are two types of transistors: bipolar junction transistor and field effect transistors. Next, transistor construction. A transistor has three regions known as emitter, base and collector. So emitter, it is an origin situated in one side of the transistor which supplies charge carriers, that is electrons and holes are the charge carriers, to the other region. Emitter is heavily doped region. Base, it is the middle region that forms two p-n junction in the transistor. The base of the transistor is thin and is compared to the emitter and its doped region. Collector, it is origin situated in other side of the transistor, that is it is opposite to the emitter, which collects the charge carriers. The collector of the transistor is always larger than the emitter and base of the transistor. So this is the transistor symbol. There are three terminals: base, emitter and collector. The transistor symbol carries an arrowhead in the emitter pointing from P region towards the N region. The arrowhead indicates the direction of the conventional current flow in the transistor. The direction of arrowheads at the emitter in NPN and PNP transistor is opposite to each other. The PNP transistor is complement of the NPN transistor. In NPN transistor, the majority carriers are the free electrons, while the PNP transistors, these are the holes. Unbiased transistor. A transistor with three terminals, emitter, base, collector, left open is called unbiased transistor or open circuited transistor. The diffusion of free electrons across the junction produces two depletion layers. The barrier potential of three layers is approximately 0.7 volt for the silicon transistor and 0.1 volt for 3 volt for the germanium transistor. Operation of NPN transistor. The NPN transistor is biased in forward active mode. Emitter base of the transistor is forward biased and collector base junction is reverse biased. The emitter base junction is forward biased only if voltage is greater than barrier potential, which is 0.7 volt for silicon and 0.3 volt for germanium transistor. The forward bias on the emitter base junction causes the free electrons in the N-type emitter to flow towards the base region. This constitutes the emitter current. Direction of conventional current is opposite to the flow of electrons. Operation of the PNP transistor. The operation of PNP transistor is similar to the NPN transistor. The current within the PNP transistor is due to the movement of holes, whereas in the NPN transistor it is due to the movement of free electrons. In PNP transistor, its emitter base junction is forward bias and collector base junction is reverse bias. The forward bias on the emitter base junction causes the holes in the emitter region to flow towards the base region. transistor current. We know that direction of conventional current is always opposite to the electron current in any electronic devices. There are three current flows in the transistors. They are emitter current, base current and collector current. Thank you.